Welcome back to swapping a 5-liter engine into a Fox platform. Now in volume 1 we took this turbo coupe and we pulled the powertrain out of it, found a donor 5-liter engine, went through it. The biggest thing we did was to install a high lift cam. Went into right much detail about camshaft profile, showed how to check piston to valve clearance, talked about valve train geometry and how all of this relates to engine performance. And we put the long block back together and we finished volume 1 by sticking the engine down into the engine bay. Now in volume 2 we will finish putting the powertrain together. We'll get the transmission in, get all the mechanicals put on the engine, do all the plumbing. We'll have to fabricate some new transmission cooler lines. We'll certainly have to make some modifications to the fuel lines because, as we mentioned earlier, most of the 4-cylinder Fox cars have fuel lines that come up the left side. 5-liter cars tend to have it come on the right side, so we'll have to make some changes there. In volume 3, it's all about wiring the car up, engine electronics. I will show you how I took a donor wiring harness, interfaced it to this car, got it to work on this engine. We'll talk a lot about troubleshooting, and I will give an engine electronics 101 lesson. I think it's very important to understand the basics on how engine electronics and fuel injection works, because when you're troubleshooting your car or you're having problems with your particular project, by having a good basic understanding of modern fuel injection systems, it will help out in that part when you're working on your project. Then lastly, of course, we'll get the engine running, get it on the road, and hopefully out to the drag strip. About a half an hour ago, I got a head start on volume 2 by installing the radiator. Now this is a replacement radiator. It should be in good shape. I think you will find that most of the Fox radiators are pretty much the same. The area that you want to be concerned about is the inlet and outlet hose diameter. I think that for this model, all of the radiators were the same, whether it was a 6-cylinder car, 8-cylinder, or the turbo coupe. When I get my radiator hoses from the auto parts store, I'll be able to verify that. I also reinstalled the stock external transmission cooler, mainly because this car already had one. I'm going to be running a stock torque converter, so that external cooler should do a good job. At a later date, if I go with the high stall converter, builds up a lot more heat, I may want to upgrade that external cooler. The stock one should be fine for now. Also, I installed the water pump. Now, I decided to go with the Crown Victoria type setup. That means that the water pump will have a standard rotation, and of course the Crown Vics had 2 belts on it. Now, the way it was set up was on the Crown Vic, you had one belt that ran the air conditioning compressor and the themactor pump or the smog pump on the right side. And then your bracketry on the left-hand side had the alternator and power steering. Now, because I'm not going to be running air conditioning on this car, and I'm not going to reinstall the smog pump, none of the right-hand bracketry needs to go on. So when I went to the wrecking yard, I made sure that, I got all of the nuts and bolts and everything in the brackets and everything from one Crown Vic from my donor car. Made sure that I got all the screws and everything, because the water pump bolts and some of the time and chain bolts are very specialized. They have a particular length, some of them are studded, and it's very hard to duplicate those bolts, so you definitely want to get that from your donor car. Now, because I'm not going to run any right-hand bracketry, a couple of the bolts wind up being too long, because normally you would have the bolts hold the brackets and hold the water pump as well. So I had to put a couple washers under 1 or 2 of the bolts. So be mindful of that. You may wind up having a bolt that actually bottoms out in the block and has not tightened the water pump. Now, the reason I decided to go with the Crown Vic setup is actually a couple reasons. One is, as I said before, I'm not going to have to run any of that right-hand bracketry, and at a much later date, if I decided to go with, say, a single turbocharger, many of the turbocharger kits that's out there have the turbo on the right side. by not having any bracketry or any alternator or anything on the right hand side, that will give me a lot more clearance. It'll make it easier to work on. Another thing is the Turbo Coupe, of course, had the alternator on the left side. Because the Crown Vic has the alternator on the left side, I should be able to reuse the stock alternator and wiring without having to add more wires to get it to go over on the right hand side, which is where it would be on a Fox setup. Now up here on top, I reinstalled the Explorer heater hose tube assembly. Now the way this works is you have two bonded hoses, they're steel pipes, and you have a little hole here for a sending unit, and over here on the intake you have another hole for another sending unit. Now I believe that the sending unit for their ECT, it's for the engine electronics, normally goes in this hole, and the sending unit for your gauge goes in this hole. I believe that there is a clearance problem with the distributor. Understand that the Explorer had distributorless ignition, so you had a clearance here, no problem. With the distributor, I believe the sending unit winds up hitting the distributor cap. So that'll have to be addressed. We'll have to see what we'll do about that. Also, you see this little small diameter hose here. Now normally you have two hoses that come off of these takeoffs on the heater hose tubes, and they go to a PCV valve heater on the Explorer upper intake. I think that was there because in cold weather you could actually form ice inside the PCV valve, and you would, of course, obviously you could get into a drivability problem. I believe here in Virginia, I don't think it's a big deal. If you live in northern states or in Canada, you might want to retain that, have those hoses go to that heater assembly on the upper intake. Now just before I get some of these accessories bolted up, I want to drop the distributor in. Now when you're putting the distributor in, there's a couple things you need to do. Of course, you need to get the engine on compression stroke #1 cylinder. Now I've already previously done that. If you had the engine all together and you had your valve cover on and you weren't sure if you were on compression stroke by looking at your rocker arms to make sure that they're closed, you could take the spark plug out, rotate the engine by hand, and stick your thumb over the hole. As you get up on the compression stroke, air will blow by your thumb. You'll get a whoop, and you know that the piston's coming up on compression stroke. When that happens, you can continue to turn the crankshaft clockwise. Now you need to do all this clockwise and bring your marks up to TDC. You should be on compression stroke #1. Then you need to line up your distributor. Now I took my distributor cap, and the cap has a little #1 marking on it that lets you know that that's the #1 tower for the distributor cap. And what I did, I lined up that tower and used a Sharpie pen and made a little mark on the little lower part of the cap so I can line up the rotor to that. Now what I want to do is to drop the distributor down in the hole, and I want to have the TFI at about, let's say, 4 o'clock position. In other words, when I look straight down into the hole, I want the distributor to be oriented something like this, where the TFI is at somewhat the 4 o'clock position. Then when I'm going down with it, I watch the rotor, and I aim the rotor a little to the left of that mark that I made on the cap, because as I drop it down, the rotor will turn to the right. So I have it a little bit to the left of that mark. So as I go down, see, it lines up. But I look, I don't have the TFI exactly where I want it. That looks more like a 5 o'clock position. That's not what I want. So to get it where I need it, I'll raise it back up, and I move the whole distributor, rotor and everything, opposite of the direction that I want to go, or actually in the direction where I want the distributor to be. Okay, see, and I got on the next tooth. Now when I drop it down, see, that lines up pretty good. The mark with the rotor lines up, and my TFI is what I would call about the 4 o'clock position. That's what I want. Now let's start. I'll go ahead and get the hole down, put it on there. And this is just temporary because I may wind up having to pull it back out. But I'll put that down there temporarily. And now I'll start getting some of these brackets on here. Now there's a possibility that this adjustment arm for the alternator does set up kind of high, so there is some risk that it may interfere with the hood. We'll have to see. If that's the case, I may have to trim a little bit off the top. I think it will miss okay though. Now for the water pump pulley, and remember all of these pulleys and brackets came from a Crown Victoria donor car. I'm using some washers on these bolts because I'm not running the radiator fan now, so the little washers will help spread the load on this pulley, hold the pulley a little tighter on the water pump. I'll use some large pliers here to hold the pulley so I can tighten the bolts. Next, I'll put the power steering pump on. I decided to go with a standard reservoir model. They're easier to find. I think it's more practical than the remote reservoir that the Turbo Coupe engine originally had. Go ahead and stick that in, put the bolts in, and torque them down. Next, I'll put the pulley on, and again, came from a donor Crown Vic. You may find them phenolic like this kind of plastic, and some of them will be metal. I decided to go with this plastic version. Now it takes a special tool to press it onto the shaft of the power steering pump, and we'll do that now. Now this little toolkit also has a remover as well as an installer, and you have to use this tool to put these pulleys on and to remove them. If you don't use the special tool, you absolutely will break the pump. Alright, and then I take the pulley and put the pusher tool right in the end of it like that, and then I'll thread the pusher tool onto the little stud that I just screwed into the pump shaft. Bottom that out. Then I'll take a wrench to hold the end of the tool, and then use an open end wrench on this part and start pressing the pulley on. Now as I tighten this down, and it takes a while to do it, I will back the tool up just a little bit and see how my progress is, because I don't want to over press it. What you want to do is to get the pulley face flush with the front of the shaft. Yeah, let me back it up, take a quick look. I don't even see the end of the shaft yet, so I've got a ways to go. Okay, let's take another look. It's got to be pretty close now. believe it's just about perfect. It's perfect. Alternator is next. Now I won't tighten these bolts all the way down yet until I get the belt on and tighten the belt. This would be a good time to go ahead and put the hoses on the power steering pump. I had to shorten the return hose just a little bit because, of course, I'm not using a remote reservoir. And we'll get the pressure line on there. It would be a good idea to put a new O-ring on this fitting. All right. Now, fair warning, these fittings that are on these pumps vary from year to year. And the fitting that was on this pump, I believe this pump was from an early Fairmont, something like that. The thread looked the same, but where the O-ring was on this pressure hose, the diameter in that fitting was slightly different. So I had to look through my bag of goodies and I found the correct fitting. I could have used the fitting from the pump that was on the turbo engine. That would have worked also. So fair warning, watch out for that. Let's get the belt on. Tighten it up. That looks good. Now off camera I did a couple things. I put the battery box in to make sure my clearance was okay with the left-hand bracketry. That looks fine. May have to remove it later to string some wires. Now the main thing I did was reroute my fuel lines. Remember I said earlier that most of the four-cylinder Fox cars had fuel lines that came up the left-hand side. So what I did, I found a convenient place on the right-hand part of the frame rail to cut the tubes. Then I took the tubing that was left, shortened it, and carefully bent and straightened as needed. Took two unions, reconnected the tubing, and mounted it here on the right-hand side. Next step is to put the AOD transmission in the car. Transmission I'm using is actually the one that I used in my AOD repair video. It was originally from a Mark 7, and the Mark 7s, along with a few other vehicles like some of the vans, had a long extension housing. That's fine, but I would have a little bit more trouble finding a drive shaft to make it work with the long extension housing. So I decided to change to the short extension housing and the short output shaft that comes from a Mustang. Most of the Thunderbirds also have the shorter length. And in that way, I should be able to use a drive shaft that I got from a donor 87 Thunderbird 5-liter car. Now, there's going to probably be some problems with getting the shifter to hook up. The shifter, of course, that's in this turbo coupe was made for a A4LD transmission, which has a slightly different quadrant. In other words, it has a overdrive position, a third gear position, second gear, and first. The AOD transmissions, of course, only have the overdrive, drive, and first gear position. So there may be a problem with that. The linkage is slightly different. The bracket that mounts to the transmission is different. The likely best setup for that would be to go to the wrecking yard and see if I can find a shifter and cable and bracket assembly from a 5-liter Mustang, or maybe even a Mark 7. Has a little bit more of an elaborate shifter mechanism. However, the cabling and the bracketing should be the same, should work fine for this. Electrically, we're not into the electrical part yet. However, the neutral switch on AOD is the same style neutral switch that's on the A4LD, so the wiring aspect should not be that much of a problem. Now, I want to put the torque converter in, and a lot of people make mistakes when they install the converter. A lot of times they don't get it all the way in. They think they're all the way in, and they're not. The best way to tell if the converter is all the way in is that when you insert it, the back part or the hub part of the converter should be below the straight edge of the bell housing. Just keep going back and forth, and let's see, that looks like that may do it. Let's take this yardstick, put it right across here, and as you can see, the hub of the converter is back behind the straight edge. Looks like I have about, at least 1/8 of an inch. If you happen to have it out too far, you think you're all the way in, and you can see that it's not, just keep turning it until it goes all the way in. Sometimes it may take 2 or 3 revolutions back and forth until it's finally all the way in. As you can see, we're in good shape. Also, you have a drain plug. I usually like to set the drain plug at the bottom and one of the studs, and then orient the flywheel in the same way. Make sure that the hole in the flywheel and for the drain plug is facing the bottom. It'll be a little bit easier to line it up as we go in with the transmission. Okay, I have the car back in the shop now. Before I start, pulling the engine out, I want to go over a couple topics. When you're working with the car, you're working with solvents, compressed air, you're underneath the car, stuff can fall in your face and in your eyes very easily. Wear some safety glasses, use a little bit of sense. The modern cars have, electronic fuel injection on it. It's nothing to have fuel pressures of 100 pounds per square inch. You may think that you've got it, safe by taking a rag and wrapping it around the line, pulling it off, and just at the last minute, a 6-foot stream of fuel comes flying out of the line. And that can get in your face and in your eyes. So you absolutely want to be careful about that. And talking about fuel, have a couple fire extinguishers around and make sure that you can get to them and that they work. A lot of times I go to people's houses, they're working on their cars and they've got a floor jack underneath the car. They've got it jacked up and they're crawling all underneath there. And that's a death wish, never do that. Get your car jacked up with a good floor jack and put some quality jack stands underneath the car before you ever get under there crawling around. Now, you're having a project that you're going to be proud of, you want to show it off. It's not going to do you much good if you're missing an eye and you have 3rd-degree burns on 2 crushed hands, So again, be safe, take your time, use a little bit of sense. Another topic I want to speak about is emissions. Now, the locality in the state that you're in, it may be very strict. If that's the case, when you do an engine swap, you will certainly have to retain the EGR system, thermactor pumps, catalytic converters, that type of thing. Some areas it may be real liberal, or maybe there's no emissions checking at all. In this video, my goal is to make sure the car is streetable, it's safe from a tire, brake, suspension type thing. I'm not going to touch much on emissions. That's going to be up to you to see how strict or liberal the area in which you live is on emissions. Raise the car up in the air. Slide the tranny under the car. Carefully bring the transmission to the engine. Line up the converter stud to the flywheel. tighten a couple bolts. Then be sure the converter studs are loose in the flywheel. If not, the converter is not all the way in the pump. Pull it out, fix it, try it again. Install and tighten the converter nuts. Remember, there are 4 nuts. I temporarily installed the crossmember and the transmission mount. Did a test fit of the exhaust and the H pipe. Took my time and bent some new cooler lines and installed the starter motor. While I was under the car doing a test fit of the exhaust pipe and the H pipe, I found that the exhaust hanger that I had from a T5 transmission is not going to work. Understand the T5 transmission mount is a little bit further forward in the car than an AOD. So therefore, when I tried to use this hanger, when I went in one direction and hit the oil pan, that wouldn't work. And when I go in the other direction, the rubber piece that engages the rod doesn't even come close to where the rod is on the exhaust pipe. It won't work. So I thought, well, I'll have to go to the wrecking yard and see if I can find one from an AOD. Then I got to thinking, well, what about the one that's on the A4LD that came out of the car? Well, this one came from the A4LD from this Thunderbird. And, you know, it looks like it would work. One side looks, you know, pretty much like what I want. The hanger part really doesn't have very much offset. It's almost in straight alignment from where the mount bolts are. But this side is way off. It has that same funny offset, and it's actually curved in the opposite direction. So I thought, well, let me cut it off and just use the one side. After all, once you bolt the exhaust into place and the H pipe is mounted on the back, it becomes fairly rigid. So if you just simply have one of the hangers, the left-hand one, and you know, put it on that rod, and I did do a test fit, it looks like it'll work fine. I think that's all I'll need. I'll have some good hangers for the mufflers in the back, so the exhaust system should float just right and be stable under the car like what we want. And talking about mufflers, well, what I did, I bought a dual exhaust kit for a Fox Mustang, and you would think, well, it should bolt pretty much right on in. But understand, the Thunderbird is a little bit longer car. So what happens, something's going to come up a little bit short. And what I found was that the muffler was a little bit too far forward. So I just simply went to the auto parts store and bought one of these little pipe adapters. So the exhaust pipe goes, you know, into the little adapter that way, and then that part goes into the muffler. And that allows the muffler to be just a little bit further back. I did a test fit, and I found by just adding that little extra bit of length, then the tailpipe goes over top of the rear end, nice and centered, should work just fine. I haven't got to the electrical part of the project, but I thought, well, this is a good time to go ahead and put the speed sensor on. Now, this car has a totally electronic speedometer, so there's no cable. Many of the Fox cars will have a cable, but whether it has a cable or not, usually it does have the speed sensor, because so many of the cars had speed control and you need that speed sensor. And even on ones that did not have speed control, the speed sensor is normally used as part of the EEC system. It gets a signal for road speed, kind of changes strategy on the fuel injection. So it appears that I should be able to just take the one out of the A4LD and put it right in the new transmission. Why not? I'm using the same rear end ratio. I'm using essentially the same size tire. The problem is the drive gear that's in the transmission that the driven gear is mated to has a different number of teeth. The A4LD that came out of the car has a 6-tooth driven or drive gear. The AOD has a 7-tooth gear. Obviously, if I put that in there, most likely the speedometer is going to be wrong. So what you do is to keep the same ratio. Think about it for a second. If the A4LD has a 6-tooth drive gear and the driven gear, and it happens to be an 18-tooth, I counted it, so you have a 3-to-1 ratio. 6 goes into 18 exactly 3 times. So on the AOD, which has a 7-tooth drive gear, to maintain that same 3-to-1 ratio, I just multiply 7 by 3. That gives me 21. So a 21-tooth gear, driven gear on this speed sensor should keep my speedometer working exactly right. The car that you're working on, there may be a different ratio. You may have a different number of teeth on the drive gear. You will have to determine that on your project. In this case, 21 tooth should work fine. While I'm under the car, figure this is a good time to go ahead and mount the TV cable for the AOD transmission. This mounts to the bell housing area here. The cable hooks to the TV linkage or the throttle valve linkage that's on the transmission. Then the cable is threaded up through the firewall area and goes to the throttle body. All right, talking about cables, might as well hook the throttle cable up. The throttle cable that was originally in this car was real short. Understand, with the 4-cylinder engine, the throttle body is very close to the firewall, so you have a fairly short cable. So what I had to do when I went to the wrecking yard and got that the drive shaft that I used for this car, the same vehicle also had a throttle cable in it too. So I took that from the donor Thunderbird. Should work just fine. It's right much longer than the original one. Okay, I'm still under the car. This is a perfect time to put the front drive shaft loop in. Now with this particular car, we're talking most likely it'll be about a 14-second car. I think the rules are, if it's a street car, you're not running true drag slicks, you really don't need to have a drive shaft loop. But I will be running drag radials, and eventually I may build the car to run faster. I think that putting a front drive shaft loop on, whether the rules tell you you need it or not, that is a good piece of hardware to put in. It's fairly inexpensive, it's very easy to install, and it gives you some peace of mind. I think it's a very necessary piece to go if you're going to build a street strip car. So we'll put that in too. Now off camera, I installed the drive shaft that I got from a wrecking yard from a AOD 5-liter Thunderbird donor car. And when I got the shaft home, I found that one of the U-joints was seized up. So I had to replace that. So what I decided to do is replace both U-joints. I mean, after all, when you get something like a drive shaft from a wrecking yard, you don't know if that vehicle had 60,000 miles on it or 260,000 miles. And on a street strip car, you know, your U-joints and drive shaft is going to have a hard life. So you should add money into your budget to certainly replace both U-joints if you're getting a shaft that you don't really have any history on. It just makes good sense. All right, now let's take a look under the hood here and see some items that I've added off camera. I've installed the upper and lower radiator hose. I just simply went to the parts store and asked for 90 model 5-liter Mustang hoses. They fit perfect. I got a bypass hose here for the water pump and thermostat. This hose here, actually, I'm not sure what that fits. I went in their back room and just simply looked over all their molded heater hoses, and I found one that happened to fit this application. I believe that little curved hose, when it's on the Explorer engine, has a 5/8 connection on the pump and a 5/8 connection here. This water pump, being from a Crown Vic, has a 3/4 pipe in this position, so therefore I'm not really sure what that hose came from, but it fit perfectly. Now over here on the firewall side, I once again just found a hose that was 3/4 on one side and 5/8 on the other, and had a fair amount of length to it. The bypass hose, which has the same dimensions, isn't quite long enough. So I had to find one that was a little bit longer, and I purposely put a little bit of a kink there, or a little bit of a bulge there. So when the engine shakes back and forth, it has a little bit of wiggle room here, keep from putting a lot of tension on the heater core. I still need to find one for this position. Now this is a very sharp 90-degree in this with this tube, so I'm going to again try to find one that's, you know, got a 90. I really need one with a little bit more than a 90-degree, maybe a 100-degree curve in it, and add a little bit of a hump to that too, just to give it you know, a little bit of shake room. I've also finished putting the transmission cooler lines on. When I fabricated the lines, you know, from the transmission and made them go around, curved them around, they only made it to about the middle of the radiator, ran out of line. So I added a union down there, got some more line, and then brought it up to this top fitting. Now you have to understand, on the AOD, the output side fitting on the AOD transmission is the top fitting. That's the one that's got the pressure on it, goes to the cooler. So I have it going around, coming up to the top fitting on the radiator. Then the fluid goes down to the bottom fitting, comes out there, makes a U-turn, goes around to the auxiliary cooler that's in the front. Then from the auxiliary cooler, comes back around to this hose fitting here to another pipe that goes to another union, which is attached to the lower tube that goes back to the transmission to the lower fitting. That's the return fitting on an AOD transmission. I still need to mount a little standoff down there to kind of support the cooler lines, you know, from vibration, and I'll do that a little later. Now, while we're talking about plumbing, to try to finish up all the plumbing aspects of the car, I need to put the fuel injectors on and mount the fuel rail. We'll do that next. Now, here's a fuel rail from a 5-liter Mustang I was able to acquire, and I have 8 19-pound injectors. Now you can always identify the 19-pound version of the injectors from the orange top, or this kind of looks tan because it's discolored, but they have a kind of an orange colored top plastic part where the wire connector goes. And you know, the injectors come in all different ranges of flow rates, and they go by pounds. You have a 14-pound injector, that would be typically on a Crown Vic, maybe some of the trucks. 19-pound would be on all of the 5-liter fuel-injected Mustangs. And I'm going to use a processor from a 89 Mark 7 LSC. The LSC version of the Mark 7 also had 19-pound injectors. 24-pound injectors are found in the Cobra version of the 5-liter. Also, I think the 460 fuel-injected motors in the trucks also use 24-pound. And you'll find 30 and 35-pound injectors. Now, they will typically be on the turbo 4-cylinder engine and on the supercharged 6-cylinder in the Super Coupe Thunderbird. Now, the way I usually install these is I take and put a little bit of motor oil or wheel bearing grease on the O-rings just to make it work a little bit easier, and stick all of the injectors in the fuel rail first. Okay, now I just remove the masking tape from the injector holes on the intake, and I'll just lower the fuel rail down onto the intake and carefully line all the injectors up with the holes in the intake. You have to be kind of octopus man here and just get everything lined up so all of them are in the holes. Then when you have all the injectors lined up in the hole, gently push down on the fuel rail to engage them in the intake. And you should see the hole line up where the bolt goes. There's 4 bolts that hold the fuel rail to the intake. And you can see it lines up nice here. Also, make sure that you can rotate each injector freely. If you can't, there's a chance that one of the O-rings have a tear in it. So make sure that they turn and they're floating okay. Looks like this is all right. Now take the 4 screws for the fuel rail and tighten them down. Okay. Now to finish up, all I need to do is install my fuel lines. Now a little tip for you here, don't just go to the parts store and buy any old fuel line. Most likely you'll get line that's made for a carburetor. It will not be strong enough for the high pressure of a fuel injected car. So always be sure, if you have to fabricate your own lines like I did, get fuel line that's specifically made for fuel injection, high pressure line. So be aware of that. All right. Take the large fitting that goes on the pressure side of the fuel rail, and these, you know, have those little garter spring connections, so you just keep going in until it clicks. Here's the return one. You'll have two plastic clips that go on the other side, and that hooks right in there like that. Now I won't install them permanently because I plan to drain the fuel tank. It has, you know, 4 or 5 year old fuel in there, so I want to get that fuel out, put a fresh filter on, put new fuel, fresh fuel in it, and then I'll permanently install the fuel lines. Okay, the next big phase to this project is to wire this car up. Now what we'll be doing is I'll reinstall some of the wires I took loose to make it a little bit easier to work in the engine bay. And I'll be grafting on a 5-liter E-harness that I got in the wrecking yard from an '87 Thunderbird. And I say grafting on because really there's almost no true plug-and-play harnesses. That is where you could just simply take your 4-cylinder harness out and put your 8-cylinder E-harness in. When I say EEC, we're talking EEC, Engine Electronic Control. You'll hear me say quite a few different acronyms as we go through the video. The reason you can't, you know, normally just, you know, unplug one and plug another one in is that there's enough differences between the 4, 6, and 8-cylinder models that you do not come up with a true 100% wire-to-wire compatibility. There's differences between the cars. You certainly have a lot of differences on this car. The Turbo Coupe tends to be unique to all of the Fox platforms. You have an anti-lock brake system, you have ride control, you have electric fans for the radiator, things that would have not been on the 5-liter version of the '88 Thunderbird. So obviously there's going to be little differences between the harnesses, and certainly you have to, you know, be aware of that. And you will find that even some of the connectors, or hard shells as we call them, the little plastic connectors that the wires come together, the male-female connection, some of those won't be compatible either. If you get an aftermarket E-harness, it's just a matter of following the instructions, and you know, you'll do pretty good. If you're going to get a donor harness like I did and you go to a wrecking yard to, you know, get one, you will be up against the same things that I was up against when I got my harness, and that is, it's unlikely you'll be able to get the complete harness because the wires wind up going, some of them go underneath the carpet back to the back of the car. You won't be able to access that typically because the seats may still be in the car and you may not even be able to get to it. You have quite a few wires that go behind the heater, air conditioner, plenum chamber. You won't be able to access that unless, you know, the AC has already been taken out of the car that you were working on. So you're going to take some side cutters and just simply snip those off. The harness that I got, I had the added problem where somebody had already taken the engine out. They had left most of the engine harness there, but they had cut some of those wires off, the wires that go to the TFI, or thick film integration, that gray thing that's on the side of the distributor. That had been taken off. So I had to find yet another car just to cannibalize that harness to get that piece. Then, you know, of course, you're going to have to figure out how you interface all of that together. This car, it's going to be fairly complicated. I'm going to go through what it took to get the harness to work on this car specifically, and I'll talk in general terms about any of the Fox platforms, what it will take to interface a 8-cylinder harness into, say, what was originally maybe a 4-cylinder car. And we'll do that. I'll go through some troubleshooting to make sure that all the wires are, you know, going to be, the ones that need to be ground are ground, and ones that are hot. And you know, if the engine should just start right up. If it doesn't, we'll talk about, you know, things we need to check to make sure that the EEC system is working correctly for our car. Now, before we get any further, I want to go over a few things that I did off camera to lead us up to this part of the project. As you can see, I've already put the distributor cap on and the spark plug wires. And remember, we're dealing with a small block Ford, so that means that the distributor turns counterclockwise. And also, because it's the high output 5 liter, it has a different firing order than the old model 5 liters from the 60s and 70s, and also the Crown Vic and the truck, which use the old firing order. So when you're putting these wires on, you start with the number 1 wire, and of course it'll have a mark on the cap to tell you where the number 1 wire is, and then you go in the firing order counterclockwise. The next one to it is number 3. The next one to that is number 7, and so on. And you know, get those wired up and put some looms on there. You'll have to remember, just as a little tip here, be careful with a couple wires. You don't want to have a few of the wires parallel to each other. They'll cause a crossfire. With the high output firing order, it just so happens that the number 6 and the number 5 fire back to back in the firing order. So therefore, the number 6 and number 5 wire should not be parallel. You should run, say, the number 7 wire between them to keep them from being parallel. The old wiring harness, or the old firing order for the old 5 liters, you had a similar problem with number 7 and number 8. They fired together in the firing order. So again, the number 7 and number 8 wires for the old firing order should not run parallel. You should make sure that those wires are somewhat separated. Now, as you can see, I don't really have too much of a problem with the wires on the right hand side as far as being too close to the headers. Got plenty of room. But on the left side here, you can see that the number 7 and number 8 is very close to the headers. In fact, the number 7 is kind of jammed between a header tube and the dipstick tube. So therefore, you see I have this little heat shield around the number 7 and number 8 spark plug boot. I hope that helps a little bit. Okay, I've reinstalled the coil and its bracket. The starter solenoid, since both of those will be in the normal location, whether it's an 8-cylinder, 4-cylinder, what have you. The starter solenoid has the big wire that goes from the solenoid down, underneath the engine, around the front of the engine to the starter motor. That's been reinstalled. The little wire here that's going from the ignition switch to the starter solenoid has been reinstalled. You have one little green fuse link, and that goes down into the body harness, which branches off to a whole bunch of fuse links you can see here, and they go to dozens of different circuits, all underneath the dash, to the air conditioning, to multiple type things. You have a new battery cable. I decided to go with the new one, and it's just on here loose right now because there'll be more fuse links that will be added a little bit later. You have the wires here that go to the windshield washer reservoir. I may reinstall that. I have the wires here that go to the alternator. Now, they wound up being a little bit short because you have to remember the alternator on the 4-cylinder model was a little bit further back, and with the alternator on the 8-cylinder, which is further forward, the wires wound up being a little bit short. But there wasn't any problem. I just unraveled a little bit of the electrical tape here, and I was able to find a little bit more of the wire lead. Gave me plenty of room. And you'll see you have this one big wire here that goes to the big battery connection on the back of the alternator. And you have the regulator wire here, and you can see there normally is 3 wires. You'll see all 3 wires will be hooked up if it has a battery light in the car. If it has an amp gauge like this car, most of the time one of the wires will be dead-ended. It will not go anywhere. And that's fairly common to most of the Ford systems. This one happens to have a Mitsubishi alternator, but whether it had that or a Motorcraft alternator, that usually stands to be pretty much the same, and that is all 3 wires are used if it has a battery light, and only 2 of the wires will be used if it uses an amp gauge. I have 2 hard shells here that I just simply reinstalled. They go to wiring to the headlights, parking lights, fog lights, that type of thing. You have 1 hard shell which was plugged in. I think it actually goes to cornering lights, which this car doesn't have, but the connector is still there for it. I've reinstalled the hard shell that goes to the windshield wiper motor. I reinstalled the little vacuum tree and this relay box. The relays that are in this little housing goes to the anti-lock brake system, so we'll retain that. The vacuum tree, of course, will have one large vacuum hose going from the intake manifold to the tree, and then from there it'll branch off to various things, to a vacuum reservoir and hoses that go to the air conditioning system, and 1 or 2 other items. Now, not all the wiring that was on this left-hand side will be reused. I have this wire here. This is to the ignition coil. Now, this is part of the harness that eventually gets to the 4-cylinder EEC harness. The 5-liter harness that I have as a donor harness has its own coil wire, so most likely this wire will not be reinstalled. I also have this little hard shell right here. Now, this hooks into the harness that eventually comes onto this side, but it is not compatible with the harness that's on the 5-liter. One wire goes to the temperature sending unit, another one to the oil pressure sending unit, one to the NOx sensor, which is not used on the 5-liter engine, and the other one goes to the oil low warning sensor that's on the oil pan. The oil pan I'm using on this car does not have the sensor. So only 2 of the wires may be used, and that is for the oil pressure sending unit and for the temperature sending unit. And of course they will have to be grafted in, added at a later time. Now, one of the wires I want to talk a little bit in detail is the ground wire. Now, this is the original ground wire that was in the turbo coupe. I had to put one of these little ends on it. I don't like using these too much, but they do work. And you have several wires coming off of it. Now, you have the main big cable that will go to your engine block or the front of the engine. If you had an older Fox car that has the battery on the right hand side, it may go down to one of the starter bolts. The main thing is to have a good ground to the engine block. Now, usually you will have another not quite as large a wire, and it will go to the fender well, or on some of the cables that were mounted on batteries on the right hand side, there may be a place on the big cable that has a little clip that is grafted to it, and it would be bolted to the frame rail on the right hand side. On this model you have the cable and it goes to the fender well area right here. Now you'll also see yet one extra little connector. This one has 2 great big wires and it goes to a real large hard shell. Now, this is common just to the turbo coupe. One of those wires wind up going to a few components under the dash area, and one of them goes to the ground terminal for the dual fans on the radiator. More importantly, as far as the EEC is concerned, one of the wires is dedicated to a 2-wire terminal set that goes directly to the PCM. The reason why you have a dedicated ground to the PCM is that processors are very vulnerable to glitches because of inconsistent grounds. You have what you call a ground loop, and that is there may be a difference in voltage potential between the ground right here at the fender and maybe the ground, say, at the rear of the car. Going through all of those weld joints and bolts and everything, the resistance may change slightly to the back of the car. Also, the ground, if you just used a ground right underneath the dash somewhere, it may be slightly different in ground potential than it is to the battery terminal itself. Therefore, you will always have a dedicated wire in an EEC system that goes directly from the battery cable terminal on the battery to the two wires that's in the EEC harness going to the processor. The 5-liter harness, donor harness, will not have a hard shell like this. So again, that's one area I'm going to have to do some modifications. Since we're on the subject of ground wires, you will always find, whether it's an EEC car or a carbureted car, you should always find a ground cable that's going from the firewall to a bolt on the back of the engine somewhere. If you remember when we pulled the 4-cylinder engine, there was a ground in this position as well. You always want to have just that little added protection to make sure that the engine and the firewall is grounded together. Now on the mechanical side, I've added a coolant overflow tank that I made out of some PVC tubing and some end caps. It should work pretty good. I've added the other hose that I needed for the heater core, but here's a little tip. I'm going to leave that disconnected. So when I add coolant to the cooling system, it will let a little bit more air get out of the block. By leaving it disconnected, the air will get displaced by the coolant, and eventually a little bit of antifreeze will probably trickle out of this hose. That'll tip me off that the system is pretty well filled. Put the hose on, clamp it down, and I shouldn't have too much trouble with air being in the cooling system. Now unfortunately, I was not able to use the dual electric fan assembly that came from the turbo coupe engine. The fan motors were a little bit too large and they interfered with the accessories on the 5-liter engine. So I wound up going with this fan assembly. It's from a Crown Vic. This particular model I think came from a 96, but I believe the 95 to 99, 2000, somewhere along that line, have the same radiator fan. It's a very large fan, moves a lot of air. Many people use the fan assembly from a Taurus, which does a good job too. I was able to get this fan, however. It's a little bit larger than the Taurus one. It's a single speed unit, and by just making some brackets here, I was able to graft it to this radiator, and I think it will do a good job for me. Controller will have to be made for it so I can get it to work with this engine. You can see I've installed the throttle cable here, and here's the TV linkage that's going down to the transmission. Of course, both of these cables will eventually hook to the throttle body when the intake is put on. I've finished installing all of the exhaust pipe, H-pipe, and the mufflers. The hanger that I fabricated from the A4LD hanger, I had to modify it slightly, had to bend it, elongate the holes just a little bit to get that pipe to set exactly where I wanted it. I have the drive shaft loop in position. I've reinstalled the main hard shell that was coming out of the floor pan that branched off to the speed control sensor and to the neutral safety switch. If your car that you're working on was a straight shift or maybe a C5 transmission, the wires going to those sensors may be different, but the main hard shell coming out of the floor pan should be the same. So if you find the correct donor harness, you should be able to plug it right back into the stock hard shell that's coming from the floor pan. The Schrader valves for the preload airbags and the rear coil springs I have mounted in the lower part of the left rear fender. So when I'm accessing and wanting to check air pressure in the tires, I can also access the air pressure in those airbags at the same time.